Well, today we move from exponential to logarithmic form. And it's a pretty simple way to go from one form to another. Here's our exponential, where we have some y equaling some base to an x. To move from exponential to logarithmic form, these two forms will be equivalent. We basically slide the base to the other side and add a logarithms. Now you'll notice if I slide base b under y and add a log, we get log base b of y is equal to x. Likewise, if I take a logarithmic form and slide the base under the other side, we get b to the x. And now remove the logarithm, I get y. So it's just sliding the base to get from exponential form to logarithmic form and vice versa. So what we're going to do here is we're going to simplify log base 2 of 8. All right? And for those of you who still aren't clear about what log is, okay, we'll see after this example basically. All right, so I don't know what this is. I'm going to call this some w value. Okay, I'm just going to throw that in there. Now I know, since I'm not really sure what this log base 2 of 8 value is, I want to put it in exponential because I'm pretty good at exponentials. If I slide the base over, I get 2 to the w is equal to 8. Now we know 8 can be written as a base of 2. That's 2 cubed. And if I know 2 cubed is equal to 2 to the w, then w equals 3. So from this example, we can really see what logarithm means. All right, we know that log base 2 of 8 is equal to 3. And by sliding the base, we know that 8 equals 2 to the third. So what logarithm really means is what power of the base is the number. Let's use this example once again. What power of 2 is 8? 2 to the third power is 8, so the answer is 3. Let's do a couple more examples. So now, I may not know what power of 2 is 1/16, so I'll put equals some unknown w. I'm going to slide the base once again, get w, 2 to the w power is equal to 1/16. I need to express 1/16 in a power of 2. I know 1/16 is the same as 16 to the negative 1 power. And I also know 16 is 2 to the fourth, which is raised to the negative 1. And that's equal to 2 to the w. This is 2 to the negative 4 equals 2 to the w. So w is equal to negative 4. And that's the simplified answer of this problem. What power of 1/9 is the fourth root of 3? I have no idea. Once again, I'll throw my w down, slide my base. So 1/9 to what power is equal to the fourth root of 3? Don't know. So what I'm going to do is change this from radical to exponential. I have 3 to the 1/4 equals 1/9 to the w. I'm going to need to get these in either a base of 9, 1/9, or 3. 3 is probably the easiest base, so that's 3 to the 1/4. This is 9 to the negative 1 to the w, which is 9 to the negative w is equal to 3 to the 1/4. 3 to the 1/4 is equal to 3 squared, because that's 9 to the negative w. Therefore, I have 3 to the 1/4 equaling 3 to the negative 2w. I can now set 1/4 equal to negative 2w. So w equals negative 1/8. Next. Now we want to solve for x. Again, we're in logarithmic form. What power of x is equal to 5? Negative 1 power. I'm still not sure, real comfortable with log equals or mean, so I'm going to slide my base and hopefully that will help me. This is 5 is equal to x to the negative 1 power. What I typically do is I try to make x to the first power. So the best way to do that is raise both sides to the negative 1 power. And then I have a power of a power. I get to multiply powers here, which gets me x to the first. 5 to the negative 1 is 1/5. And that's my solution. Moving on. All right, so we're looking at logarithms now, and here are some properties that we learned back in Algebra 2. If I have the log base a of a product of two terms, that splits apart into the sum of the independent logarithms, or the sum of the factors. If I have a division of two quantities, that will split apart into the difference of each of those quantities. And then finally, if I have the log base a of some number raised to a power, I can rewrite that as power sliding out in front times the log base a of p. All right. We're going to use those to continue our problems. I want to now solve for x. Now, I see in this example here, in this first example, that I have a 2 multiplied by a logarithm, which means I use that third property and bring that up here. So I have the log base 3 of x is equal to the log base 3 of 4 squared. Now notice, one logarithm on each side, and they both have the same base. If that's true, then that must mean the quantities inside must be equal. So x must equal 4 squared, or 16. Now in this next example, we see a sum of two terms with the same log base. So therefore, I can rewrite that as the product of those two terms. This gives me the log base 4 of 3 times 2. So I have the log base 4 of x equaling the log base 4 of 6. And therefore, since I have one log base on each side, the quantities of those log bases must be equal. So x must equal 6. Moving on. Now, you'll notice in this case, I have the log base 5 of some unknown is going to equal this large quantity here. And you'll notice I have two terms out in front, so both of these must go up into my powers. So I have the log base 5 of 8 squared minus the log base 5 of 2 to the 5th. This gives me the log base 5 of 64 minus the log base 5 of 32. Now you'll notice I have a difference of two logs. A difference of two logs can be combined into a division. So the log base 5 of 64 over 32 gives me the log base 5 of x. You'll notice once again, one logarithm on each side, therefore their quantities must be equal. And 64 over 32 is 2. And now we have a problem where we have the sum of two logarithms. Sums can be simplified into a product of those two terms. So this goes to x plus 1 times x plus 5 equals 1. And you'll notice this problem is a little bit different because there's not a logarithm on each side. The log base 7, I get to multiply these together now, of x squared plus 6x plus 5 is equal to 1. Now the only way to solve this is get it in exponential form. So I'm going to slide the base once again, get x squared plus 6x plus 5 equals 7 to the first, which is 7. Since it's quadratic, set aside equal to 0. X squared plus 6x minus 2 is equal to 0. All right, you'll notice now that in this case, this does not factor. That doesn't mean there's not an answer. We use a quadratic formula. So we have negative 6 plus or minus square root of 6 squared minus 4 times 1 times negative 2 over 2. This should get me two answers. Those two answers are a positive 0.32 and a negative 6.35. Now let's investigate these a little. When I plug them back into my equation up here, the 0.32 is fine, but the negative 6.31 is not. That being because when I plug that in, what power of positive 7 equals a negative 1 point whatever, or a negative 5 point whatever when I come over to this side? All right, I cannot raise any positive number to a power to yield a negative number. So therefore, this is an extraneous answer. My only answer in this case is 0.32. You cannot have the log base any number equaling some negative number. Next. Here are the questions I'd like you to answer today. We'll see you tomorrow.